Let's continue with the further questions in this exercise. The 10th main question, the first part, it tells us that if f of x is given to us, and that's the function for x not equal to pi by 2, you need to make it continuous. Okay, they've said that the function is continuous at x equal to pi by 2. Then what will be f of pi by 2? If the function is continuous at x equal to pi by 2, you will simply say that f of pi by 2, that should be equal to limit of x tends to pi by 2 f of x, and in place of f of x we will write whatever function they have given to us, that is root over 2 plus sine x minus root 3 the whole divided by cos square x. Now whenever you see a root, all you need to do is rationalize, and that is how we proceed with our simplification. So when we rationalize, we have root over 2 plus sine x plus root 3 divided by root over 2 plus sine x plus root 3. In the numerator it is root a minus root b into root a plus root b, and that will be root a square minus root b square, that is simply a minus b. So it will be 2 plus sine x minus 3 in the numerator. So that should give us sine x minus 1 in the numerator, and in the denominator cos square x can be written as 1 minus sine square x. 1 minus sine square x is again of the form a square minus b square, so we can write it as 1 minus sine x into 1 plus sine x. From the numerator you can pull out a minus 1 common from the two terms, and that should give you minus of 1 minus sine x, and that 1 minus sine x can be cancelled in the numerator and denominator. After that you can simply put x as pi by 2 in the leftover expression. So you will have f of pi by 2 as 1 plus sine pi by 2, that is 1 plus 1, which is equal to 2. So this bracket, it gets evaluated to 2, and when you put x as pi by 2 here, this will be 2 plus 1, that is root 3 plus root 3, that makes it 2 root 3. So into the second bracket being 1 upon 2 root 3, and the final f of pi by 2 value, that turns out to be equal to 1 upon 4 root 2. I'm sorry, 4 root, this was a 3 here, so 4 root 3. Yeah, so f of pi by 2 finally will be equal to 1 upon 4 root 3, and that is how you are answering this question. Going ahead with the second question, they have again given us f of x, and that's the function for x not equal to 0. They have said that it is continuous at x equal to 0. We need to find f of 0. So again, f of 0 will simply be limit of x tending to 0 f of x, and in place of f of x we write the function that they have given to us, which is cos square x minus sine square x minus 1 upon root over 3x square plus 1 minus 1. Like we did in the previous question, every time we see a square root, all we need to do is rationalize. So we will multiply this with root over 3x square plus 1 plus 1. In the denominator also we will have root over 3x square plus 1 plus 1. A minus b into a plus b, that makes it a square minus b square. So we are going to have root over 3x square plus 1 minus 1, and this term gets combined with it. So plus 1 minus 1 gets cancelled, and we are left with simply 3x square in the denominator. Let's write that 3 along with the second term. So I'll write that 3 here separately along with this. And yeah, in these two terms what we can do is we can pull out a minus sign common from all of them. So if I am pulling out a minus common, we will have minus of 1 minus 1 minus cos square x minus sine square x. Okay, so what we can do is, so we have 1 minus cos square x plus sine square x after pulling out that minus common, and 1 minus cos square x will be sine square x. So 1 minus cos square x will be written as sine square x. Sine square x plus sine square x will be 2 times sine square x. So we have minus 2 sine square x as the numerator, and we can rewrite that as minus 2 into, we can write it as sine x upon x the whole square. Now after you split the limit, the first term will remain as minus 2. One limit goes along with this bracket, and that limit can be taken inside the bracket here. So we will have limit of sine x upon x, where x tends to 0. So the value for it will be 1. So we have 1 square as the value of our next term, into, put that x equal to 0 here, because this limit, when it attaches itself with this term, you can put x as 0 in this expression. So that will give you root 1, which is 1, plus 1, which is 2, upon 3, that would be 2 upon 3. So the value for f of 0 turns out to be equal to minus 4 upon 3. Yeah, so that's how we are answering the second question. Going ahead with the third one, we are given f of x, and again in a similar way they are saying that the function is continuous at x equal to x equal to pi. So we need to find f of pi. F of pi will be limit of x tends to pi, and f of x is 4 power x minus pi plus 4 power pi minus x minus 2, the whole divided by pi minus x, x minus pi, the whole square. Now we will take x minus pi as h. So if x minus pi will be h, we know that x tends to pi, that is x is approximately equal to pi. If x is approximately pi, x minus pi means h will be approximately equal to 0. If h is approximately 0, we can say h tends to 0. So this limit gets converted to limit of h tends to 0. This term is 4 power x minus pi, but x minus pi was h. So we have 4 power h plus 4 power pi minus x is the negative of this. So this will become 4 power minus h minus 2, the whole divided by this itself was, this was h. So in the denominator it is h square. Now in the numerator you can say that 4 power minus h is 1 upon 4 power h. If you combine all these terms, that is by taking an LCM, you will have 4 power h the whole square. This will get multiplied with 4 power h. So minus 2 times 4 power h, and in the end plus 1, the whole thing divided by 4 power h. You can keep that 4 power h and h square together in the denominator only. The entire numerator is the expansion of 4 power h. It's the expansion of 4 power h minus 1 the whole square. So the numerator is being written as 4 power h minus 1 the whole square, and a square upon b square can be written as a upon b the whole square. So we have 4 power h minus 1 upon h the whole square. So the limit is going to get split now. One limit goes with this, the other limit attaches itself with this. That limit can be taken inside the bracket. So we will now have the limit value for this expression as its limit of h tends to 0, a power h minus 1 upon h, the value for that will be log a. So the value for this entire bracket will be log 4 the whole square. And when you put h as 0 here, it will be 4 power 0, which is equal to 1. So the final value for f of pi, it's turning out to be equal to log 4 the whole square. So f of pi, we just saw it is log 4 the whole square. Yeah, that's how we are solving our question number 3. And with that we go ahead with the 11th question, where they have already given us f of x and they are saying it is equal to k for x equal to 0, and they have said that it is continuous at x equal to 0. So find k. It's again the same thing. F of 0 should be equal to limit of x tends to 0 f of x. F of x is 24 power x minus 8 power x minus 3 power x plus 1, the whole upon 12 power x minus 4 power x minus 3 power x plus 1. Now f of 0 itself is equal to k. So the value of k will be the solution to this limit. It's very clear that these expressions are going to get factorized. So when you factorize the numerator, on factorizing it, it's like this 24 power x can be written as 8 power x into 3 power x. You can pull out 8 power x common from here. So that will give you 8 power x into 3 power x minus 1. From these two terms, you can pull out a minus sign common. So that will give you minus of 3 power x minus 1. 3 power x minus 1 can be taken out common from the two terms here and here. So that will give you 3 power x minus 1 into you will have 8 power x minus 1. Similarly, if you factorize the denominator, that is going to give you 3 power x minus 1 into 4 power x minus 1. So you can cancel off 3 power x minus 1 in the numerator and denominator. And then you can divide the numerator and denominator with x. So that will give you 8 power x minus 1 upon x divided by 4 power x minus 1 upon x. If you split the limit, Then in the numerator you have an expression of the type a power x minus 1 upon x, the value for which will be equal to log a. So in the numerator it is log 8 divided by the same thing in the denominator will give you a log 4. So log 8 you can think of it as log of 2 cube, and 4 can be written as 2 square. This 3 can come out of the log and this 2 also can come out of the log. So you can write it as 3 log 2 divided by 2 log 2. Log 2 gets cancelled in the numerator and denominator, and finally the value for k turns out to be equal to 3 by 2. So for this question the final answer is k will be equal to 3 by 2. Going ahead with the second question. F of x is given, it is equal to k for x equal to 0, and they have said that the function is continuous at x equal to 0. So to find k we can say that f of 0, that should be equal to limit of x tends to 0 f of x. F of 0 is already k. We are writing our f of x as 5 power x plus 5 power minus x minus 2 the whole divided by x square. 5 power minus x is like 1 upon 5 power x, and when you combine all these terms in the numerator you have 5 power x the whole square plus 1 minus 2 into 5 power x the whole divided by 5 power x. We can write that 5 power x and x square together in the denominator, and the numerator is the expansion of 5 power x minus 1 the whole square. So a square upon b square, we can write it as a upon b the whole square. So we will write it as 5 power x minus 1 upon x the whole square. If you split the limit that goes with this, you have the value of it as 1 upon 5 power 0, that is 1 upon 1, multiplied by the limit that goes with this bracket. You can take that limit inside the bracket, and the value for this expression will be equal to log 5. So we will have log 5 the whole square, and so the value of k finally is log 5 the whole square. Yeah, so that's how we are solving the second question. We go ahead with the third one. So we have our function f of x defined in this manner for x greater than 0. For x equal to 0, f of x value is given to us as 4, and for x less than 0, the function has been given to us as x square plus b minus 3. They are telling us that it is continuous at x equal to 0. So find a and b. If it is continuous at x equal to 0, we can say that f of 0 should be equal to the left hand limit as well as the right hand limit. So this will be limit of x tends to 0 minus f of x, that is the left hand limit. So this will be limit of x tends to 0, f of x tends to 0 minus means x will be slightly less than 0, and for x less than 0 the function is this. So we will write f of x here as x square plus b minus 3. We can put f of 0 as 4 because that has been given to us. That will be equal to the value for this limit. To evaluate it, just put x as 0. So when you put x as 0, you get the value for this as b minus 3. So we have 4 is equals to b minus 3, that's the value of this term. So we have the value of b equal to 7. In a similar way, you can evaluate even the value for a. So we will say that f of 0 will also be equal to the right hand limit. So the right hand limit will be limit of x tends to 0 plus f of x. And for 0 plus, f of x will be written as sine 2x upon 5x minus a. We have done that because x tends to 0 plus means that x is slightly greater than 0, and for x greater than 0 the function was this. So we have written f of x for x tends to 0 plus as this function, and to evaluate it we can take this 5 outside the limit. So we have limit of x tends to 0. We took that 5 outside. We will bring a 2 here and balance it by writing a 2 here. The value for this limit will be equal to 1 because it's of the type limit of theta tending to 0 sine theta by theta. So we have okay, b was 7, let's keep that. F of 0 was equal to 4, that will be equal to this term, and this term gets evaluated to 2 by 5 into 1 minus a. So if you solve it, a will be equal to 2 by 5 minus 4, and that should be equal to 2 minus 20, which is minus 18 divided by 5. Yeah, so a will be equal to minus 18 upon 5, and that's where you have the values of a and b right there with you. Okay, so with that we go ahead with our next question. Again, you need to find a and b, given that this function is continuous for all values of x. If it is continuous for all values of x, it is continuous at x equal to 0 also, and it is continuous at x equal to 2 also. So we will say that for this function, at x equal to 0, the left hand limit and right hand limit will be the same. So limit of x tends to 0 plus f of x, that should be equal to limit of x tends to 0 minus f of x. So for the right hand limit, that is when x is greater than 0, the function will be this. So we are writing f of x here as x square plus 3a minus b. On the right hand side, that will be limit of x tends to 0. X tends to 0 minus means x less than 0, for which the function is this, that is ax plus 2b plus 18. All you need to do is put x equal to 0 in the given expressions. So that will give you 0 plus 3a minus b equal to, here it will be 0 plus 2b plus 18. You can take that 2b on the left. So that will give you 3a minus 3b equal to 18. And cancel off a 3 in the entire expression. So you will have a minus b equal to 6. That is your equation number 1. In a similar way, try to frame your equation number 2. That is, let's keep that equation the way it is. And let's make changes in the expression here only. The given function is continuous at x equal to 2 also. So we will say that limit of x tends to 2 plus f of x and x tends to 2 minus f of x. They will also be equal. That is, the right hand limit at 2 and at minus 2 will be equal, because the function is continuous at x equal to 2 also. So let's write a 2 here and a 2 here. And for x less than 2, that is for the left hand limit, for x less than 2, the function is x square plus 3a minus b. So I am writing for the left hand limit, the function as x square plus 3a minus b. And for the right hand limit, that is for x greater than 2, the function is 8x minus 2. So for the right hand limit, we are writing the function as 8x minus 2. Put that x equal to 2 here. So you have this condition as 16 minus 2, which is equal to 14. That should be equal to, put that x as 2 here, 4 plus 3a minus b. That 4 goes on the left and it becomes equal to 14 minus 4, which is equal to 10. So 10 will be equal to 3a minus b, and 3a minus b equal to 10 is your second equation. All you need to do is subtract equation 1 and equation 2. So equation 2 minus equation 1, that will eliminate b, and that should give you 2a is equals to 4. So a will be equal to 2, and when you put the value of a as 2 in any one of the equations, be it 1 or 2, let's put a as 2 in equation 2. So when you do that, you have 6 minus b equal to 10. So we will have 6 minus 10 equal to b. So b will be equal to minus 4. And yeah, that's how we are solving the fourth question. With that, we go ahead with the fifth question. And again, in a similar way, you need to solve this one as well. So you are given that the function is continuous. You need the values of a and b, and you are given that the function is continuous for all values of x. So if it is continuous at x equal to 2, we will say that the left hand limit and right hand limit at 2 will be equal. So limit of x tends to 2 plus f of x will be equal to limit of x tends to 2 minus f of x. For the right hand limit, that is for x greater than 2, the function is this. So we will write limit of x tends to 2. For the right hand limit, we are writing our function as ax square minus bx plus 3. For the left hand limit, that is for x less than 2, the function is this. So here we will say limit of x tends to 2, x square minus 4 upon x minus 2. We can write that x square minus 4 as x plus 2 into x minus 2. X minus 2 gets cancelled. So we are left with x plus 2. And when you put x equal to 2 in this expression, this becomes 2 plus 2, which is equal to 4. Evaluate this. We will put x equal to 2 in this expression. So we will have 4a minus 2b plus 3. After substituting x, the limit will not be written. So now that 3 goes on the right, and you have 4a minus 2b equal to 1. That is your equation number 1. In a similar way, try to find equation number 2 by considering that the function is continuous at x equal to 3 also. So limit of x tends to 3 plus will be equal to limit of x tends to 3 minus of f of x. So now at x equal to 3, the right hand limit, that is for x greater than 3, the function will be 2x minus a plus b. So this condition becomes limit of x tends to 3, 2x minus a plus b, that should be equal to limit of x tends to 3. We are writing the left hand limit now. So left hand limit means for x less than 3, the function is this, that is ax square minus bx plus 3. Evaluate this limit by putting x equal to 3 here. So that should give you 6 minus a plus b. And on the right hand side put x as 3. So you will have 9a minus 3b plus 3. To simplify that, you can take that a on the right hand side and even b on the right hand side and take that 3 on the left hand side. So you have 3 is equals to, this goes here, so we have 10a, b goes there, so minus 4b. So yeah, we have 10a minus 4b as 3, that's our equation 2. And to solve equation 1 and 2, all you need to do is multiply this equation 1 with 2. So on doing that, we will have 8a minus 4b is equals to 2. Subtract the 2 of them. So when you subtract the 2 of them, you have minus 2a is minus 1. So a will be equal to 1 upon 2. Put that a equal to half in let's say equation 1. So when I put a as half here, I have 4. That 4 goes on the right, makes it minus 2. Minus 4b is minus 2. So b also will be equal to half. And with that, we get the values of a and b, which were required for the 5th question. So yeah, that's how we are solving our 5th question. And with that, we go ahead with the 12th one. You need to discuss the continuity of the function f on its domain, where f of x has been given to you. You can simply plot a graph. Of course, I am not doing it mathematically, but it's okay even if you do it by plotting a graph. Not in your exams, but you can understand it by simply plotting the graph. So mod of x plus 1, it will have a vertex at minus 1, and it will be a V-shaped graph like this, where this line and this line, both of them are making this 45-degree angle with the x-axis. That's the graph only for values of x which are between minus 3 and 2. So let's draw that again. So this is minus 3 and let's say this is the number 2. The graph is going to look like this. This is the number minus 1. So the graph is going to look like this, a proper V-shaped graph. And from 2 to 7, from 2 up to 7, the graph will be for mod of x minus 5. This will have a vertex at x equal to 5. It's not exactly at the center, it is closer to 7. But now, whether this graph, that is mod of x minus 5, the graph of it, the graph for this, will it be of this type? Or it will be somewhere a little bit up or a little bit down. So to check that, what we should do is we should evaluate the y coordinate here. So if I just put x as 2, I have the y coordinate here as 3. So this point is the number 3. And if I put x as 2 here, I have 2 minus 5, which is minus 3. But the modulus for it will be equal to 3. So even for the second function, the coordinate here will be equal to 3 only. So this graph is going to go like this, have the vertex at 5, and it will keep on increasing like this. If I put x as 7, I will have 7 minus 5, which is 2. So the y coordinate at 7 will be equal to 2. There will be a solid circle here because 7 is a part of the interval. For the blue function, that is for this function, there should be a hollow circle here. But if I consider this function, then x equal to 2 was included in the domain, and that is why this part will be a solid circle for the orange function. And now if you see, the entire function can be easily drawn without lifting the pen. That is, you have this, then this. Without lifting the pen, it goes on from here, and then this. So the function is continuous at every point which you have in the domain, and that is our final conclusion, that the given function f of x is continuous for all possible values of x. So we can say is continuous for all possible x values, that is for all x which are belonging to real numbers. Yeah, that's how we are answering the 12th question, and we go ahead with the 13th one. You need to discuss the continuity of f of x at pi by 4, where f of x has been given to you. So let's try to evaluate limit of x tends to pi by 4 f of x. If this will be equal to 3 by root 2, then it is continuous. If it's not equal to 3 by root 2, it is discontinuous. Of course, at pi by 4. F of x, that is the function, has been given to us as sin x plus cos x the whole cube minus 2 root 2 the whole divided by sin 2x minus 1. Well, we can actually pull out a minus common from here and write it as 1 minus sin 2x. Sin 2x can be written as 2 sin x into cos x, and the 1 here can be written as sin square x plus cos square x. Now this entire thing, the entire bracket in the denominator, becomes the expansion of sin x minus cos x the whole square, or cos x minus sin x the whole square, whatever you may call it. And now what we can do is we can write this term. It is sin x plus cos x. So sin x plus cos x can actually be written as root 2 times sin x into 1 by root 2 plus cos x into 1 by root 2. Now sin x into 1 by root 2, that's like sin x into sin pi by 4, plus this is like cos x into 1 by root 2. So 1 by root 2 is written as cos pi by 4. So sin x into sin pi by 4 plus cos x into cos pi by 4, that will be cos of pi by 4 minus x. So we have cos of pi by 4 minus x as the value of sin x plus cos x, and that thing of course multiplied with root 2. And that sin x plus cos x is what we will replace with, the sin x plus cos x that we have in the numerator, we will replace it with this term. We actually have the cube of sin x plus cos x. So if we are taking a cube of this term, the cube of this term will be root 2 cube, that is 2 root 2, and the cube of this bracket. So the cube of this term will be cos cube pi by 4 minus x. So we are replacing this term with 2 root 2 into cos cube pi by 4 minus x minus we had 2 root 2. From this term and this term you can pull out a 2 root 2 common. So that will give you 2 root 2 cos cube pi by 4 minus x minus 1. And similarly in the denominator, you have cos x minus sin x the whole square. So if you have cos x minus sin x, what you can do is write this also as root 2 into cos x into 1 by root 2 minus sin x into 1 by root 2. Let that 1 by root 2 be written as sin pi by 4 and this 1 by root 2 be written as cos pi by 4. So in the denominator you have sin pi by 4 cos x minus cos pi by 4 sin x, and that can be written as the expansion of sin pi by 4 minus x the whole square. Sin pi by 4 minus x, but in the denominator we have the square of it. So the square of this will be the square of the full term here. So when you take a square of that full term, we have root 2 square which is equal to 2, and the square of this bracket which can be written as sin square pi by 4 minus x. So that is the denominator's term, that is minus of 2 sin square pi by 4 minus x. Now this 2 cancels off a 2 here. So we are left with a negative sign here which we will write in the numerator. So we have a minus root 2. Then we have this entire term and then we have this entire term. Even in the denominator, sin square theta, that can be written as 1 minus cos square theta. So we can write our denominator as 1 minus cos square pi by 4 minus x, which was our theta. This minus can be taken inside the bracket here. So this bracket will be 1 minus cos cube pi by 4 minus x. And this bracket is of the type a cube minus b cube. So we can write it as a minus b into a square plus ab plus b square. So we will have 1 minus cos of pi by 4 minus x multiplied by 1 plus cos of pi by 4 minus x plus cos square pi by 4 minus x. That completes your numerator. In the denominator, this can be written as 1 minus, it's of the type a square minus b square. So you can write it as a minus b into a plus b. So 1 minus cos of this term, and that will further be multiplied with 1 plus cos of pi by 4 plus x. So 1 minus cos of pi by 4 minus x gets cancelled in the numerator and denominator. And now in the leftover expression, to evaluate the final limit, you can just put x as pi by 4 in, like I said, the leftover expressions. So when you put x as pi by 4 in the leftover expression, the value for the full thing becomes, let's just rewrite that again. So we have 1 plus cos of pi by 4 minus x plus, in the end we had cos square pi by 4 minus x. So plus we have cos square pi by 4 minus x. That's your numerator. In the denominator you have this term. So that term I'll just write it separately over here. So we have 1 plus cos of pi by 4 minus x. Now when you put x as pi by 4 in the leftover expression here, so we have 1 plus cos 0, which is equal to 1 only, plus this will also be cos square 0, which is again equal to 1 square, which is 1. In the denominator this will be cos 0, which is again equal to 1, and 1 plus 1 in the denominator will be equal to 2. So this root 2 and 2 get cancelled, and we are left with a root 2 in the denominator, and the numerator becomes equal to 3. No need to write the limit again after you have substituted the value of x. So the value of limit x tends to 4 f of x turns out to be equal to 3 by root 2, which is equal to f of pi by 4, and that is why we can say f of x is continuous at x equal to pi by 4. With that, we go ahead with the 14th question. You need to determine the values of p and q such that the following function is continuous on the entire real number line. So if this function has to be continuous, we just need to redefine this limit. Mod of x minus 2 greater than equal to 1 means that x minus 2 will be greater than 1, or x minus 2 will be less than minus 1. So there's an equal to sign also along with it. So we have greater than equal to 1 or less than equal to minus 1. So from here we have x greater than equal to 3. From here we have x less than equal to 1. Okay, so for x greater than equal to 3 and less than equal to 1, the function is this. So you can say for x less than 1, it is x square plus px plus q. And for, you can just write it separately, that for x greater than 3, this is the function. So now if it is continuous everywhere, if the function is continuous everywhere, we will say that limit of x tends to 1 minus f of x should be equal to limit of x tends to 1 plus f of x. That is, left hand limit and right hand limit at 1 must be equal. So the left hand limit at 1, the function for it will be x square plus px plus q. So we have limit of x tends to 1, x square plus px plus q. And limit of x tends to 1. For the right hand limit, that is for x greater than 1, the function is x plus 1. To evaluate the right hand side, we can just put x as 1. So the right hand side will be 1 plus 1, which is equal to 2. On the left hand side, put x as 1. So this term will be 1 plus p plus q. So when that 1 goes on the right, we have p plus q equal to 1, and that is equation 1. Similarly, if we try to evaluate one more condition between p and q, we have to say that the function is continuous at x equal to 3 also. So the left hand limit at 3 should be equal to the right hand limit at 3. To simplify that, we can just say that for x tends to 3 minus, that is for x less than 3, the function is x plus 1. So on the left hand side, that is this part, becomes limit of x tends to 3, x plus 1, and the right hand limit, that is the limit for x tends to 3 plus, that is for x greater than 3, the function is again x square plus px plus q. Put x as 3 here, so you have 3 plus 1. That should be 4. On the right, put x as 3 here. So we have 9 plus 3p plus q. So you can take that 9 on the left and you have a minus 5 there. So minus 5 is 3p plus q. So we have 3p plus q as minus 5. That is equation 2. Now to get the values of p and q, just solve the two equations. That is, if you subtract 2 minus 1, you have 2p as minus 6. So p will be equal to minus 3. And put that p as minus 3 in this equation. So you will have q as 1 plus 3, which is equal to 4. So yeah, here's where you have the values of p and q for the 14th question. Going ahead with the last two questions in this video, that is the 15th and the 16th one. You need to show that there is a root for this equation lying between 2 and 3. It's very simple. All you need to do is take this entire thing as f of x. So f of x is 2x cube minus x minus 16. If we try to evaluate f of 2 is 2 into 8, which is equal to 16, minus 2, which is, okay, minus 2 and minus 16. So that will be equal to minus 2. So f of 2 is minus 2. Similarly, try evaluating f of 3 because 3 was the next term. So f of 3 will be 2 into 27, that is 54, minus 3, minus 16. So that will be 54 minus 19, which is equal to 35. So you see that f of 2 is negative and f of 3 is positive. Because f of 2 into f of 3 is a negative number, it is very clear by property that there will be one root lying between the numbers 2 and 3 for this function. So if this function is having a root between 2 and 3, you can say that the value for this will be equal to 0 between 2 and 3, and that is why this equation is having a root between 2 and 3. Similarly, if you try to solve the 16th question, you can say that we will take f of x as x cube minus 3x, and we need to show that there is a root between 1 and 2. So f of 1 is 1 minus 3, which is equal to minus 2, and f of 2, that is 8 minus 6, which is equal to 2. So again, f of 1 and f of 2, they are both of opposite signs, that is, one is positive and the other is negative. So f of 1 into f of 2 is negative, and that is why we can say that this function has a root between 1 and 2, that is, the value for this will be equal to 0 somewhere between 1 and 2, and that is why this equation is having a root between the values 1 and 2. That's how we are answering the 15th and 16th questions. And with this, finally we are done with all the sums of exercise 8.1 from the Maharashtra government textbook, 11th standard maths part 2. I hope whatever sums of continuity that I have discussed in this video have been someplace somewhere helpful to you in your preparations. Thank you for watching.